Hello everyone. In this video, we are going to discuss about finite automata. It is a mathematical model which has no memory. The uses of finite automata are it is used for checking the behavior of the digital circuits, and it is used for constructing the lexical analyzer phase of the compiler. The lexical analyzer reads the characters in the source program and groups them into tokens. Then the third use is pattern matching in a large bodies of text. For example, if we want to search a word or phrase or sentences in a web page, then this model can be used. And a finite automata consists of set of states and transition among states based on the input symbols. There are two types of finite automata: deterministic finite automata DFA and non-deterministic finite automata NFA. So in this video, we are going to discuss about DFA and one example. DFA means for each input, only one transition is possible from the current state. For example, from state Q0 and the input symbol is 0 means it may go to Q1 or Q0, but both the transition like this is not possible. This is not possible in DFA because from the state Q0, 0 goes to both Q0 and Q1. This is not possible. So this is wrong in DFA. So for each input symbol, there is only one transition is possible from the current state. So but this is possible in non-deterministic finite automata because in deterministic finite automata the next state is determined, the transition is determined. So we can formally represent a DFA by DFA D equals Q sigma delta Q naught F, where D is the name of the DFA, Q is a set of states of the DFA, sigma means input alphabet, delta is a transition function. So in a DFA, delta can be represented like this: delta of Q comma A equals P, where Q represents current state, A is an input symbol and P is a next state. That is, from state Q to state P, if there is a transition on the symbol A, then it can be represented like this: the delta function of Q comma current state comma current input symbol is equal to next state. Then this Q0 represents start state of the DFA and F means set of final or accepting states. So the Q0 and F belong to Q. Now we can see one example, construction of a DFA to accept the strings that start with 10. That is, all the binary strings that should start with 10. So the string 10010 is a correct input string because this string starts with 10, or 1011 is a correct input string, 100. So these are all the correct input strings. These strings must be accepted by our DFA. Suppose the strings start with 0010, 010. These are all the strings should be rejected by our DFA. So there are three representations. One is transition diagram, list of transition functions, and third one is transition table. First we see the transition diagram for this problem. So all the strings that start with 10 must be accepted by our DFA. So we can start with the state Q0. Assume that Q0 is a start state. So in a transition diagram, start state is normally represented with an arrow leading to that state and a word start. This arrow should be labeled by the word start. And the string must start with 1. So from Q0 to Q1, draw an arc and that arc should be labeled by 1. That is, if the first symbol of the input string is 1, then our transition must be changed to Q1. That is, we need to reach our final state. So if 1 is the input symbol, then state should be changed to Q1. And next input symbol must be 0. So from Q1 to Q2, draw an arc, and that arc should be labeled by 0. This is state Q2. So all the strings start with 1 0 means then we will be in state Q2. So after recognizing 1 0, whatever the input symbols may be, any number of zeros and ones, state must be in the same state. We need to consider Q2 as a accepting state. Normally the final or accepting states are represented with the double circle. So after recognizing 1 0, for all the input symbols, state must be in the same state. So for example, consider the first input string. The transition is changed for the 1, Q0 changed to Q1. Then for 0, it reaches to Q2. Then for 0, it remains in Q2. Then for 1, it remains in Q2. Then again 0, it remains in Q2. So this input string is accepted by our DFA. 1011 means 1011. These are called as self transition 100. So this DFA accepts all the input strings that start with 10. And assume that suppose from Q0, if 0 is a input symbol, then it should go to a dead state. QD, we can write this as a dead state. Or you can, there is no need to draw this transition at all. Then from Q1, similarly from Q1 also, if 0 is a tape symbol, state change to Q2. But if 1 is a tape symbol, then it should reach the dead state. Sorry, for the input symbol 1, Q1 goes to dead state. So if 0010 is the input string, then 0, for 0 it goes to dead state. Then for the second symbol 0, there is no transition from the dead state. So this input string is rejected by our DFA. Similarly for 010, we will always start from the start state Q0 only. So for the input symbol, first input symbol 0, it goes to QD. Then for 1, there is no transition from QD. So this is also rejected by our DFA. The second format is by writing a list of transition function. We can write it like DFA D is equal to set of states. Here the set of states are Q0, Q1, Q2. There is no need to write the dead state. Then the input symbols, set of input symbols are 1 and 0. Then transition function delta, that should be listed afterwards. Then start state Q0, and the fifth tupule is final state. Final state is normally represented with the braces because one or more states may be final states. Then we need to write all the transitions. Here we have 4 transitions, 1, 2, 3 and 4. There is no need to write these. If you want, we can write it. So delta of Q0 comma 1 equals delta current state comma current input symbol. Current state is Q0, current input symbol is 1, next state is Q1. Similarly, from Q1, 0 is a tape symbol, 0 is the input symbol, it goes to Q2, next state is Q2. Then from Q2, there are 2 transitions. So delta of Q2 comma 0. Q2 and 0 goes to Q2. Then delta of Q2 comma 1 equals Q2. These are the list of transitions. Third representation is transition table. In transition table, rows correspond to states and columns correspond to input symbols. So there are 3 states, Q0, Q1, Q2. So Q0, Q1, Q2. These are used for representing 3 rows, and columns are the input symbols, and entries are the next state. And normally in a table, start state is represented with an arrow. In this example, start state is Q0 and final state is Q2. Final state is represented with the star. Then we need to fill all the transitions here. We can refer the transition diagram or list of transition functions. So Q0 comma 1 is Q1 means for the row Q0 and the column 1, there is the next state Q1 that should be listed here. Q0 comma 1 goes to Q1. There is no transition for 0, so we can put a hyphen over here, or you can write QD, dead state. Then Q1 comma 0 Q2. Q1 comma 0 is Q2. Q1 comma 1 is not a transition, so put a hyphen. Then Q2 comma 0 is Q2, and Q2 comma 1 is also Q2. Thank you.